Canada-France-Hawaii telescope. He's a resident astronomer there. He's been working on Mauna Kea, specializing in adaptive optics and interferometry since he came over from the Paris Observatory as part of his PhD project in 1994. So he has a lot of experience on the mountain. He's also chairman of the Ohana project, which is a really cool thing where they want to link up all the observatories to create one massive simulated observatory up on Mauna Kea. But he's not here to talk about that tonight. Tonight, the title of this presentation is called Moving Mountains, Flank Collapses, Giant Landslides, and Mega Tsunamis. So we'll let him explain that, but I know where I want to be if there's a big tsunami on the Big Island. I'm going to come right up to work, get some overtime hours. But with further ado, Dr.
Thank you, and good evening. So, as Kelly mentioned, I'm an astronomer, and I'm going to be talking about geophysics today. This is not my field of expertise, but I should maybe say a few words about tsunamis. The reason I got interested in this is in 2006, in October 2006, we had an earthquake at the Big Island, and I lived down in Fukuoka, which is by the coast. And it turns out the epicenter was actually 6 miles away from where we live. Now, we rushed outside and tried to get to high ground because we figured, there might be a tsunami or something. And this got me thinking about how tsunamis occur and, the kind of scale of the events that we're talking about. As we're standing there on the highway looking out, I was expecting a mountain of water to keep coming. And there's a lot of myths and false conceptions about tsunamis and mega tsunamis. So tonight we'll go through some of the evidence that we can come up with about whether mega tsunamis exist or not. So I based this talk on a number of papers, and in fact, if you look at this field is fairly recent. I would say maybe 25 to 30 years is when most of the papers have come out, and it's basically a series of 3 papers spaced 10 years apart. In 1984, this paper by James Moore, deposit from a giant wave on the island of Lanai, Hawaii. Then in 94, a paper by James Moore again called Giant Hawaiian Landslides. And then in 2004, a paper by Gary McMurdy from the University of Hawaii at Manoa, Mega Tsunami Deposits on Kohala Volcano, Hawaii from Fan Collapse of Mauna Loa. So these are the 3 main papers that kind of define this field of study. And then to me, the thing that kind of cinches them together is a paper that came out in 2001 by Stephen Ward and Simon Day called the Cumbre Vieja Volcano, Potential Collapse and Tsunami at La Palma, Canary Islands. These guys were really the first ones to nail down the simulations of tsunamis and mega tsunamis, and I'll spend some time on that. Now, all this relates to theories and hypotheses. So to start off with, is there anything that we can, find out from experience, from people having experienced things? So there was a paper that came out in 2007 by Patrick Nunn called Geological Histories and Geohazard Potential of Pacific Islands Illuminated by Myths. And this was a very interesting paper that goes into the fact that the Western Pacific Islands have been inhabited for 3,000 years, and most of them have had a very strong oral history. And the idea is it possible to reconstruct geological events from these myths? So it's very difficult because you have to select which myths you take into account, and you have to take into account the fact that there are cultural details in many myths. So what you're looking for is something that may be common to a lot of Pacific Islands, or common themes to Pacific Islands. For example, islands being fished up or thrown down by gods is a common theme that comes up over and over again. And some myths can be highly localized also, and in that case, it could be a recollection of traumatic events such as an island disappearing or a catastrophic wave impact. So this idea of fishing up islands is quite common. In fact, it's usually related to a god or a demigod who drops a line into the ocean where he knows that an island exists and drags it up. it is likely that many such myths occurred around shallow underwater volcanic eruptions. And there have been quite a few of those within human history. I'll show you a little map later. In fact, these myths may have traveled from active volcanic zones to islands which are much older. And the common feature is the name of the fisherman. This is what's interesting, is that this has traveled all around the Pacific, Maui, or his father, Tangaloa. And these myths are thought to have originated around Tonga. So this is an example of what an underwater eruption would look like. This was the Kabachi volcano in the Solomon Islands in 2002. And you can see if you see this in the distance, or if you're sailing by and you're trying to find reasons for this, these are cataclysmic, violent events. The idea that something is being brought out from under the water could become realized. The idea that islands are thrown down is also quite common throughout the Pacific. And there, the idea is that there's a god flying or taking steps over land and throwing down land on where the islands are going to be on the land below. And this is interpreted as a volcaniclastic material raining down or settling on an area following an eruption. And in fact, there are many active volcanoes in the Southwest Pacific that the ancestral Tongan and Samoan passed by on their way to settle further east. You see here New Zealand, and all these triangles here are shallow water volcanoes that are likely to have erupted within the last 3,000 years. You see Tonga here, Samoa here, and so you can imagine sailing through here as the Polynesians populated the Marquesas, the Tahitian Islands, and the Hawaiian Islands, how they came by all this active volcanism. Now, diluvian stories about floods, are also very, very common in the Pacific. It's one of the most common myths in the Pacific. It's very, very difficult to separate from storm surges or tsunamis or earthquake activity or large rains. However, giant landslides may be associated with these surges, as we will see. This is the topic of the talk. The flank collapses can help to, if you find the theme of the flank collapse in myths, this may help to establish the timeline, the recurrence of these type of events. So what is a flank collapse? In a flank collapse, you have a volcanic island, which is just barely under the surface of the ocean, and parts of the flank collapse and make a talus on the side, and then the island becomes unstable, it becomes lopsided on one side, so you usually get a secondary gravity slide, and you're left with talus on either side and the volcanic shore. Now, as this happens, the islands disappear underwater. And in fact, there are probably around 30 islands that have disappeared in the Pacific that have been identified through myths, and 9 actually have been fully authenticated. That is, the islands, the submerged remnants have actually been found, and they match in terms of timeline with the myths. 17 are unsatisfactory, but like we said earlier, it's not a one-to-one relationship. Myths can travel. And in fact, there appears to be hotspots of flank collapse around Vanuatu and Marquesas, and to a lesser extent, Papua New Guinea and Yap. So in this paper, they analyze all these myths. In fact, they go into a lot of detail about the islands that disappeared, the islands of Vanua, Tuanahe, and Burutu. And they find that the recurrence time between these flank collapses is on the order of 200 to 400 years, is when you can expect these kind of events. Now, to put this in broader context, I'm going to just go over some basic of geophysics so that we understand island formation a little bit better. If we look at the Earth, very quickly, there is an inner core, which is solid. It's about 1,200 kilometers in radius. Then there is an outer core, which is liquid, and it extends to about 3,000 kilometers below the surface. And then from minus 3,000 to minus 35 kilometers is the viscous mantle. And then from 35 kilometers to the surface is the crust, the solid crust, the lithosphere. And there is an interesting layer in the mantle between minus 100 and minus 700 kilometers called the asthenosphere.